Have you ever just stared at a problem, completely stuck, not knowing where to even begin? Well, it turns out the secret to cracking some of the most complex challenges lies in a word you hear all the time: the algorithm. But what is it really? Forget the tech jargon for a second. It's a fundamental way of thinking, a powerful tool for solving, well, just about anything. So let's break it down.
Here's how we're going to do it. First, we'll talk about why we even need a strategy for problems in the first place. Then we'll get to the heart of it, what an algorithm actually is, using an analogy you already know. After that, we'll see one work its magic, figure out what separates a good algorithm from a not-so-good one, and finally, we'll see just how these invisible instructions are quietly running our world. So, let's start with that all-too-familiar feeling of being faced with a big, messy, chaotic problem. And to really get what I mean, let's try to solve one right now, together.
Okay, imagine this. I hand you a list of 50 totally random numbers, and your job is to find the biggest one. Simple, right? But how do you actually do it? Where do you start? Do you just start guessing, comparing a few here and there? It seems easy, but without a clear plan, it can get surprisingly messy. This is pretty much what an unstructured problem feels like to our brains. It's just chaos. Without a system, we can feel totally overwhelmed. We might just scan the numbers, pick one that looks big, and kind of hope for the best. And that approach, it's not just inefficient, it's a perfect recipe for making mistakes. Now, we do have a few ways to tackle this. The most common one is just trial and error. Try something, see if it works. If it doesn't, try something else. It might get you there eventually, but it's often a long, winding road. Luckily for us, there's a much, much better way. And that better way is, you guessed it, the algorithmic approach. This is where we stop guessing and start following a guaranteed step-by-step plan. So what is an algorithm? Honestly, the best way to think about it is as a recipe. That's it. A recipe gives you a list of ingredients and a precise set of instructions to follow. You follow them correctly, you're guaranteed to get a cake. An algorithm does the exact same thing, but for solving a problem. Okay, here's the more formal definition. But there are two words here that are absolutely key: finite and well-defined. Finite just means it has to end. It can't go on forever. And well-defined means every single step is crystal clear. There's no guesswork, no ambiguity. The main takeaway here is that an algorithm is basically a foolproof guide. So now you can really see the difference, right? Trial and error is just haphazard. It offers no guarantees. But an algorithm, it's systematic, it's methodical, and it guarantees you'll get the right answer every single time. It's the difference between wandering around in the dark and following a perfectly lit path.
All right, enough with the theory. Let's make this real. We're going to go back to our number problem and actually put an algorithm to work.
Okay, we're back to our list of 50 numbers, but this time we're not going to guess. We're going to apply a simple but super elegant algorithm to find that largest number. So what's the recipe? It's incredibly simple. 4 steps. Step 1. We just assume the very first number on the list is the largest one we've seen so far. Step 2. We look at the next number. Step 3. We compare. Is this new number bigger? If it is, great, it becomes our new largest. If not, no big deal, we just move on. And step 4. We repeat that simple comparison for every single number on the list. By the time you get to the end, you are guaranteed to have the right answer. That's it.
And this is what those steps start to look like when we get them ready for a computer. This is called pseudocode. It's not a real programming language. Think of it more like a structured blueprint. It's a way to write down the logic of our recipe so that it's easy for a human to read before it gets turned into actual code that a computer can run. It's the perfect bridge between our idea and the machine's instructions. And that is such a key point. Algorithms don't just magically appear. Someone, a person, has to deeply understand a problem, think through the logic, and design a step-by-step strategy from scratch. They are a product of pure human thinking. A person has to write the recipe before the computer can even start cooking. But, just like in the kitchen, not all recipes are created equal, right? Some are fast and elegant, others are slow and clunky. So what actually makes an algorithm a good one? It really comes down to 3 main things. First, and most obviously, correctness. Does it actually work? A good algorithm has to give you the right result every single time. Second, efficiency. How fast is it? How much memory does it need? The goal is to solve the problem using the least amount of resources possible. And finally, clarity. Are the steps easy to understand? Can someone else follow your recipe?
And let me tell you, efficiency is a huge deal. For our little list of 50 numbers, it might not matter much, but imagine you're sorting billions of web pages like Google does. The difference between an efficient algorithm and an inefficient one could be the difference between an answer in a split second versus waiting for days or even years. It's that critical.
And this brings us to the final, and maybe the most mind-blowing part. These recipes aren't just for computer science class. They are the invisible engines that are running our entire modern world.
Just think about your day. When you search for something, an algorithm sifts through billions of options to give you the most relevant ones. When you scroll your social media feed, an algorithm is deciding exactly what to show you. That autocorrect on your phone? An algorithm. Your GPS finding the fastest way home, dodging traffic? You got it. That's a brilliant algorithm at work. They are literally everywhere.
So when you boil it all down, an algorithm is the core logic, the essential idea behind every single piece of software. It's the intelligence that turns a hunk of metal and plastic into a powerful problem-solving machine. They really, truly are the backbone of our digital lives.
So let's end with this thought. If algorithms are just recipes, these carefully crafted step-by-step instructions for getting something done, then it forces us to ask a really important question. Who's writing them? Who are the chefs in the kitchen, and what values are they baking into the recipes that now guide so much of what we do and see? It's a pretty powerful idea to think about.